Hello folks, here's a short video all about required practical number 1. Now the title of this practical is an investigation into the effect of a named variable on the rate of an enzyme controlled reaction. But specifically, that named variable is going to be temperature. So what we're doing is we're looking at how temperature affects the rate of an enzyme catalyzed reaction, and the enzyme we've chosen to use, you might just be able to make out on this beaker, is trypsin. This is a trypsin solution in here, and trypsin is an enzyme that digests a substrate called casein, which is actually in milk. So here's our solution of milk. This has got the substrates in it. We're going to be breaking it down using this, and we're going to be doing it at different temperatures. Okay, so as temperature control is really important for this, we're going to be using a water bath. This is our water bath. It's not very high tech. It is a beaker with a thermometer in it, and I have a kettle with which I can add hot water. The range of temperatures we've chosen to use in this is from 20 to 50 degrees, going up in 10. So we're going to do 20, 30, 40, 50, and I suppose if we have time we could always do 60, but we're going to start aiming for those. So 60 I reckon is our absolute upper limit on this one. So right here I'm just setting up my results table. Let me show you what that looks like. Okay, so we have the temperature, and that's the range, and then the time for X to appear. Now that will become clear in a moment what that's all about. But first things first, I'm going to talk you through the experimental setup. So I'm going to start off at 20 degrees. So this water bath has been sitting at 20 degrees. You can hopefully make out that we are pretty much bang on 20. So this is at exactly the right temperature for my first experiment, and I need to set up what I'm going to do. So let's get a test tube rack out, and for each experiment you are going to need 6 test tubes. Okay, now the way we know when the experiment has reached an end point, or when the enzyme's done its work, is that this liquid here, that is cloudy at the moment, will go clear. When you've broken down the protein, the casein in here, the liquid will stop being cloudy. And in order to detect that, what we're going to do is use the very sophisticated technique of putting an X on each test tube, and we're going to be looking through it, and when we can see that X, we would say that the experiment has run its course. So on these 3, I'm putting an X. Notice where I'm putting it. It's not at the top, it's relatively far down the test tube. And there's a reason for that that will become apparent in a moment. I've tried to be relatively consistent with the size and colour of my X so that they are all the same, because obviously that would be a variable we need to keep the same. So now what I need to do is I need to get some substances ready for the reaction. And the first thing we're going to do is we're going to get 10 centimetres cubed of our milk solution. Okay, so this is a 10 centimetre cubed syringe, and I'm going to put that in here, and this one, and this one as well. Okay, so now what we're going to do with the other 3 test tubes, these 3 here, we need some other things. And these things we're putting in here are to make sure that the enzyme is operating in constant conditions. So if you think about the factors that affect enzyme action, temperature, well, we're already controlling that and changing it. What else affects them? Well, substrate concentration, well, I've controlled that in here because this is all the same milk solution. But pH is important. So I'm going to use a buffer alongside my trypsin. So here's the buffer, and it's a pH 7 buffer. So it's going to keep the pH in all of these test tubes, when we mix it together, is going to be at 7, and it's going to stay there, which is good. So let's put 2 centimetres cubed of this into here. And again, we're doing this 3 times. Okay, so there's my buffer. And now it's time to add the enzyme. I'm going to add 2 centimetres cubed of trypsin. This is a 1 centimetre cubed syringe, so 2 of those go into each of these. got 1, 2. So that one's now got the enzyme. 1, 2. 1, 2. So what we have here, substrate and buffered enzyme ready to go. So we've obviously got enough for 3 experiments. Those are our repeats right there. Time to get our water bath back. Still at 20 degrees, you'll be pleased to know. And what we're going to do is we're going to put all 6 tubes in there. And this is the period of the experiment known as equilibration. I need to make sure that the contents of those tubes is at 20 degrees as well. And that's going to take a little while. So, the way to be sure, start a stop clock, and we're going to leave it for 10 minutes. Okay, so as you can see, our 10 minutes is nearly up, which means that equilibration should have happened. Everything in here is now sat at 20 degrees and we're ready to do the experiment. So, what I'm going to do is I'm going to take 1 tube of enzyme and 1 tube of milk with an X, okay, and I'm going to mix it. And I need to mix it reasonably well, hence the bung. So when it goes, invert it, that's now mixed, and I'm going to leave that in there. Okay, this tube, now empty, let's put it back in there. And I'm going to do the same with all of my 3 setups. So in goes the enzyme on that one. Give it a quick mix. And the reason why I'm doing this as speedily and as efficiently as possible is because we are going to start the timer when all 3 are going. In it goes. Okay. So we've inverted, we've given them all a good mix, and now I'm going to start the timer. Now I am looking for the moment at which I can see that X from the other side. A couple of my X's just start just to come off ever so slightly, so I'll have to make sure I look very carefully on those. But I'm looking for an X becoming visible through this liquid as the enzyme breaks it down. This is my lowest temperature, so think about what you know about enzyme kinetics. This is the one that's going to take the longest. Whilst that's going, I know from experience that I have a few minutes until I need to really pay attention to that. So we're going to take a moment just to discuss doing the next temperature. But when you do this for real, you can't really take your eyes off that, because if you miss it and you look back and suddenly those X's are visible and it's all gone clear, you've missed the end point. You don't know how long the experiment took. But we are going to discuss how we do our next temperature. It's 30 degrees. So we're going to need to make a water bath at a higher temperature. So this is where I'll be doing this water bath. And of course you're going to use a kettle. Now you need to be aware that whatever I put in here, whatever temperature it's at, let's have a little look. It's not going to stay that constant, is it? Because we took 10 minutes for equilibration and now there's going to be quite a while for this experiment to take place. The temperature of this is going to tend to decline back towards room temperature. So you will need to keep an eye on it. Now this is currently sat at, it's a little bit too high actually, it's actually at about 45. So if I put a bit of cold in there, I can bring it back down to 30. But once that reaches 30 and I can start my next experiment off and get ready to equilibrate that, I'm going to have to keep topping it up with warm water, just a little at a time, making sure I can keep it at the right temperature level. You don't want it suddenly dropping down. This will be most of an issue when you get up to your highest temperature. Obviously 60 degrees it's going to cool down far faster than 30. So you will need to keep an eye on your water bath and do a bit of topping up with the warm water to keep it at the right level. Okay, so whilst that's just getting to its next level, we'll leave this going. It's going to take a few minutes, so there's our stop clock. I'm going to pause the video for a little while. Okay, it has been a few minutes. In that time, I was keeping one eye on this. I actually managed to set up my next experiment, so this is now at 30 degrees in the water bath, equilibrating. But I've just cast my eye back this way, and I think if you start looking closely, you can, in fact, see an X through the milk. It has gone clear enough that I can now signal that as the end point. Now I've got 3 tubes in here, so this one is obviously visible, so I can write down the time at which that's 6 minutes 45 seconds. So 20 degrees, I'm going to convert that to seconds. Okay, so 405 seconds. Let's have a quick check. That one I don't think is quite visible yet, so I've looked at the other tubes and they're not quite visible. So it's just that one. So I'm going to put that one in the rack. I'm going to keep an eye on those to get my repeats, and as soon as they're visible I'll be able to write them down in my results as well. Okay, I've now made a judgment. I believe I can see an X through that. Okay, that's 7 minutes 50 seconds. Okay. And again, that one, I'm pretty sure I can now see an X through that. So again, I'm taking that one out. And that was about 8 minutes. Okay, so I've got my first set of results, 3 repeats for those test tubes at that temperature. That was 20 degrees. What I'm now going to do is I'm going to just pause the tape and do 30 and 40 degrees exactly the same way. Then I'll have a look at one that goes a little bit faster at 50 degrees. But I'm sure by now you're getting the idea of how this experiment works. Okay, so I've done 30 and 40, and I've literally just this minute mixed the enzyme and the milk at 50 degrees. So start the stopwatch. Now, I've done this one because it, in theory, should go a little bit quicker. So we're just going to keep our eyes on that. Now, one thing I will say about this experiment, at the end of it you're going to have a lot of test tubes with partially broken down milk and enzyme in it, and you need to dispose of that. It can go down the sink, but you do need to rinse the test tubes out, because otherwise they have this kind of nasty dairy residue on them. And give us a whole class of test tubes like that, it's going to start to smell a bit like a cheesemonger. Okay, so when packing this one up, you've got to clean up after yourself reasonably well. This one's been going barely 30 seconds. I hope you can see that it's already starting to look a little bit clearer. I can now see the X through that, so that's about 45 seconds at 50 degrees. So that one has, as we might have expected, it has broken it down much, much quicker. Okay, so 45 seconds on that tube there. In fact, I can now see this one's really broken down. You can see that that one is completely clear now. So those are my timings. Obviously I haven't tested all these, we've still got to do 60 degrees, but no, hopefully now you see the method. And you might have an idea of what will happen when we get up to 60 degrees. Are we going to see this trend continue? So there are my results so far. Okay, you can think about what you might see when we go up to the higher temperature. You should also consider how you will present these results. We've got 3 repeats at each temperature. What do we typically do when we have that kind of data? And how could we represent this graphically? What would it look like? But that is pretty much all there is to Required Practical 1. Hope that was useful.